So, does everybody hear me? It's 3:30. I think we can begin. Today I'd like to share with you about how we manage big data at NHN Corporation. And particularly it's about MySQL database sharding. First, I will introduce who NHN is, what we do, and the overall assets that we manage. And then I will review briefly about the sharding in production, the existing solutions that are provided. Then I will explain about why we decided to create our own tool for sharding, which can be used for both CUBRID and MySQL databases. Then I will probably have time for a demo, and where I'm going to use 2 virtual machines for sharding. And at the end, I will conclude with an explanation about N-Drive service at NHN, where we use CUBRID sharding production. So my name is SN. I work at NHN Corporation as CUBRID project and community manager. And so before I continue, I'd like to ask if anybody ever heard about NHN. Yeah, right. So anybody heard about CUBRID database? Not too. So I will explain them. I will introduce. So NHN, even though you never heard, is the largest internet company in South Korea. It's actually the 13th largest internet company in the world after Yahoo and Alibaba. So according to market capitalization, so it's quite big. It manages search engine in South Korea and Japan, and mainly works in gaming industry too. So we have lots of web servers and thousands of database servers. Mainly NHN is a world of relational database systems. So we use MySQL, we use Oracle, Microsoft SQL too, and CUBRID as well, so, and other NoSQL solutions too. So when we talk about sharding, we have to talk about relational database systems. So, and we should admit that relational database systems are still in the business. Lots of corporations in the world rely on relational database systems. And at NHN, we use RDBMS because of the fact that it provides data consistency. This is what we need. And mainly, most of our data at NHN are somewhat related to each other. And RDBMS provides relationship out of the box. So that's why we love RDBMS solutions. And we have over 500 terabytes of data to manage in relational database systems. So we somehow have to find out the solution how to shard all this data. So we've done some research some years ago on the existing solutions, and there are open source and there are commercial systems, and we've divided these existing solutions into 4 categories, and I will stop on each of these listed solutions later. And there are 4 categories that that describe the existing sharding solutions. One is the application layer, the other is on the storage layer, for instance, storage for MySQL, and also there are heavyweight and lightweight solutions. So before explaining the reasons why some solutions are not applicable to NHN, I have to first explain about NHN's web services. So I can say that there are 2 characteristics which mainly describe web services at NHN. First is that they are stable. So we have services which has tens of millions of users and unique visitors daily. And there are some web services which have over 180 million users. So our services are stable. And when we want to introduce some sharding solution, we don't want to change our application. Our application code is stable, so we don't want to change anything. So we want a solution which will be working out of the box. We could just drop and it will work. So that's what we want. That's what our goal. So considering these, the application layer solutions like Hibernate ORM and the HiveDB, which is based on Hibernate, they require application change, major change. So on the application layer, the application should decide where the data should be distributed to, which shard, and so on. And that's not suitable for us. We don't want to change our applications. So it's not the solution for companies or for solutions like ours. And the solutions which are based on the storage, like Spider for MySQL, they require you to change the storage of your end database. And this is, again, not what we want. And other solutions like heavy middlewares, they are really good, actually, and they provide high performance. And DB-SHARD, for instance, is quite well known in the market, and they also provide commercial support, and briefly, they're really good. But in order to maximize your benefit from DB-SHARDs, you have to tightly bind your application with DB-SHARD's drivers, and you have to also install agents on each of your shard machines. And this is not exactly what we want. So we don't want to change our application, and we don't want extra layers on our databases. And regarding the Blizzards, which was introduced, which was opened by Twitter in 2010, was quite a hit back then. But if you look at their GitHub repository, it's not active since early 2012. So for our stable, heavy, high-load services, we don't want solutions that are not maintained anymore, even though they're open source. So that's why we avoid these kind of solutions. And we somehow agree on using a lightweight solutions like Spark Proxy, which is based on MySQL proxy. And the good thing is that you can use this solution and you can just drop between your application and your backend databases, and it's going to work. It doesn't require you to change your application. It's really nice. And so with a little configuration on the Spark Proxy side, and you're ready to work with sharding. But the one kind of caveat of Spark Proxy is that it's somewhat performance limited in the way that it's, first of all, performs full SQL parsing whenever the SQL request comes from the application. So on top of that, it also rewrites the SQL itself and then sends the rewritten SQL to the target DB. So that's one of the reasons why its performance may suffer. So before we learned about this solution, we kind of forecasted that if we're gonna put this solution under the same load as our services, it may simply not handle that, and it will just die. So, and for that, we run the tests. Actually, we run the tests after we've created our own solution too. So, I will show the graph a little later. And if we look at Spark Proxy, it contains all its configurations in a dedicated universal DB database, which is MySQL too. And where there it also has all the rules for sharding the database. And briefly, it parses the SQL, and it's a single-threaded, which is also a reason for low performance. So when we ran the tests, we noticed that when you increase the number of simultaneous connections for Spark Proxy briefly cannot handle over 400 and 500 connections at the same time, which is not what actually what we want. And that was the reason why we decided to create our own solution, which will provide basically everything what Spark Proxy provides. That is, it will be lightweight and it will be maintained by us, and it almost will not require any application change. So that was our goal. But we wanted the new solution to be very high performance, so that it does not hinder the performance of the already running solution, already running web service. So we've created the CUBRID chart on top of existing CUBRID database, which is developed by our company. I will briefly introduce CUBRID itself a little later. So main purpose of CUBRID chart is to be light and very easily and intuitively to configure. And if we compare with Spark Proxy, if Spark Proxy configuration is stored in the database, in CUBRID chart it's stored in 3 only files with very intuitive parameters to configure. And instead of parsing the SQL, actual CUBRID chart does not parse SQL at all. So we briefly searched for a certain SQL hint, and based on that hint, we map with the chart ID and send the SQL unchanged to the target chart ID, the chart database. And but still, one weakness of CUBRID chart is that you have to change your queries. Not the application code itself, not the logic, but the queries itself to add the chart ID, which will help the CUBRID chart to identify the target chart ID. And CUBRID chart is based on CUBRID database. CUBRID is open source relational database, quite similar to MySQL. We support over 90% MySQL SQL syntax in CUBRID. And NHN is fully supporting this project, and major features of CUBRID is the native support for scalability. That is, it comes with native sharding and HA in 3 different modes. But in this presentation, I will not talk more than this about CUBRID, as it's not about CUBRID, but about CUBRID chart. So I will go directly to the CUBRID chart architecture. So CUBRID chart is a middleware. So it stands between your application and your database engine. When the CUBRID chart actually consists of 3 types of processes, like broker process, proxy, and CAS process. And there are 2 types of CAS process for MySQL and for CUBRID database. So when your application requests some connection, the broker process actually receives first that connection. It listens for connection requests. So once the connection request is received based on its internal load balancing policy, passes this connection request to one of the proxies, one of the available proxies. So, and the proxy establishes the connection, and further on, all the query requests, like select and insert requests, they are received by proxy, and then proxy sends based on its internal policy to one of the CAS processes. So CAS process will handle actually all the querying, executing querying. And in case of MySQL, CAS MySQL will talk to a particular target MySQL database. So every database will serve as a dedicated physical shard. So there can be, you can have multiple machines where you can install CUBRID charts in parallel. So they would provide you a failover and load balancing for your application. And CUBRID chart has API level load balancing. And then once the queries will go to one of the shards, they will briefly talk to the same set of MySQL shards. And installation is really easy. We provide binaries which you can download from our official site, and they're also available on repositories, Launchpad, Yarn, and my favorite way of installing CUBRID chart is through Chef. Does anybody use Chef? there's one person. If you don't use it and you want to provision or prepare some remote servers automatically, like for example what you do in Amazon servers, then Chef is really good solution. So in my demo today I will show how Chef will allow you just run one command and configure and install multiple servers automatically. So configuration is really easy too and very intuitive. Briefly, all the process is like you create your databases on remote machines, you create database users there, you create same or optionally create some non-sharded tables too on each database shard. So once your remote shard databases are ready, you go and configure CUBRID shard. CUBRID shard requires to configure only 3 files, which I will explain a little later. And once your configurations is ready, you just start CUBRID shard, and then in your application you change the connection URL and add the SQL headings. So this is all it's necessary to use CUBRID shard. So we will go step by step. You go on each of your hosts on each your machine and create a MySQL database. So once they are created, you create user for each database, and then you briefly create same schema for the tables that you want to shard on each machine, so that they're identical and CUBRID shard can refer them without an error. So, and then once your machines are ready, you go and configure CUBRID shard. In CUBRID shard there are 3 files: shard, shard connection, and shard key. In shard, you briefly configure CUBRID shard itself, like you set the database name for single database view, which will be used by your application. And then you set there the database name, the username, and the password. In the connection, you briefly tell CUBRID shard where your remote shards are located. That's all. That is the remote database name, the host name, and the port number. That's all. And in CUBRID shard, in shard key configuration file, by default, CUBRID shard provides modular-based sharding strategy, and in that shard key file, you can defines the rules, that is ranges of some shard key which will be mapped to target shard ID. So I will show it a little later. So first configuration file, which is shard, requires to configure 4 parameters. There is you set the single database view name, which will be used by your application. Then you say the database username and password, which will be used to connect to your CUBRID shard. And they should be same to connect to all your shards. And then in the application server parameter, you briefly say if you're using MySQL as a backend, then you say cost for MySQL. If you're for CUBRID, then you omit, which will default to CUBRID itself. So in our case, we use cost for MySQL. And in shard connection, second configuration file, we briefly indicate the ID and the target database. That is, we map the shard IDs with the remote shards. So we say, for instance, 0, which will be mapped to ShardDB database, which is located in first MySQL A host on port 3306. So this way you list all your shards that you want to be available in your CUBRID shard. So in the last configuration file, you briefly say, mention the ranges of shard keys, which should be matched to a particular shard ID. In our case, by default, CUBRID's modular strategy is 256, which you can change in shard configuration file. And if by any reason you want to configure your own library, which will determine the shard ID, like you have you want not by modular, but by time, by something else, or you have some complicated algorithm to calculate that, you can use your own library. And in CUBRID shard, you just define the path where your library is located and the function to be called in order to get the shard ID for a given shard key. So in that way, it provides lots of flexibility. So, and then you go and start your CUBRID shard on one of your machines where you want to run CUBRID shard. And in your application, you have to change two things. First is connection URL. In the connection URL, this is the JDBC example. There are other drivers as well to other languages. And you first have to indicate where CUBRID shard is located. That is host, the port, and then the single database you name. So in our case, it's ShardDB and the username and the password. And there are two other optional parameters that you can use. If you define a list of alternative hosts, like in this case, 2, 3, 4, and so on, those alternative hosts will be used by your application driver, in our case JDBC driver, for failover, for application layer failover. That is, if your application tries to connect or tries to send a query to a main shard, CUBRID shard, and is not getting the response during some timeout period, it will quickly relay the request to a next shard, which is in alternative host. So you have failover on your API level with CUBRID shard. And if you enable load balancing, the same set of alternative hosts will also be used for loading the queries, or load balancing the queries. That is, it will use internal logic for distributing evenly on all nodes to all CUBRID shard nodes. And the second thing that you have to change in your application is the queries. So you don't have to change your application logic. So application will work as it is, but you have to change your SQLs that are used in your application. And you have to add an SQL hint. There are three types of hints that are available in CUBRID shard. First is shard key, which indicates to a column whose value will be used to determine the shard ID. So in that shard ID mapping that we configured in shard key configuration file. So the second hint is shard value. So this is in case your query does not include a column which is sharded, which is used for sharding. So in that case, you can specifically indicate which value should be used to determine the shard ID. And the third hint is the shard ID. So if you want to, for some reason, to execute query against a particular shard, you can do that. You simply specify the ID of shard in this hint. And the CUBRID shard will bypass the shard identification logic and directly send the unchanged query to the target shard. So overall, the process looks like this. Your application has some query, sends the request to CUBRID shard. CUBRID shard finds the hint, and based on that hint value, will determine the shard ID. And then send the unaltered SQL that was received from the application to the target shard. And then once received the result, it will return back the result to the application. So I will now show a quick demo. Very good. So in this demo, since the memory of my laptop is limited, I can run only 2 virtual machines. And on each virtual machine, briefly, we will have we will have two virtual machines on different IPs, and on both of them we will have MySQL installed, and I will also install CUBRID Shard on the second one. So the second virtual machine will have MySQL as well as CUBRID Shard. And that CUBRID Shard middleware will distribute data to these both MySQL instances. In our case, I will use CUBRID version 9.10, and I name the Shard DB as Shard DB, and I say that Shard hosts are located in the same machines. That is, I already indicated here. So they should be the same. So, and for MySQL, I use this password. So this is the configuration file for Vagrant. Has anybody heard about Vagrant? Oh, good. So this is briefly the kind of instructions for Vagrant to create two virtual machines. And to save time, I've already created these machines, and they are now just empty. And this briefly says that two machines are now up and running. I can SSH into them, like node 2. In node 2, CUBRID Shard is installed together with MySQL. And I can go and, do I have? Yes. I can connect to MySQL on node 1 or node 2, optionally. And I can now check use Shard DB, which was our name, and check if it's empty. Yes, it's empty. So briefly, in your case, you would make sure that your databases are created. And now, then after the databases are created, what you have to do is populate the databases with same schema. So this is what we're going to do. I will say that I have a schema here. There is one table that I want to shard, which is called table post, and sharding will be done based on post ID column. So briefly, this will be populated into both machines. And I say MySQL, so done. So now both MySQL instances have the same schema. So I created a set of Java and Node.js examples, which I will show today. I can actually, this demo is available on GitHub, so you can later download, fork, and try yourself. It's going to work out of the box for you if you have Vagrant and VirtualBox installed on your machine. So I will go to JDBC, for instance, or I can go to Node.js directly. And then I have three just separate scripts which will demonstrate here how we select, insert, and empty the shards. So I'll have one select all, the code which will briefly execute select. Does everybody see what's written here? No, right? It's not very visible. It briefly says select star from table posts, and in SQL hint it says shard ID 0. That means this SQL will be executed against the shard 0, which is located in node 1. And if we put shard 1 in the second, here, this is shard 1, and this is shard 0. So we have two queries. Just to make sure that both of them are empty. So this script indicates that both shards are empty. So if we now run the second example, which it will insert 5,000 records on both virtual machines. Actually, it will just instruct CUBRID Shard to install insert records wherever they should be, based on 256 modular. So it will take maybe some time to insert them because they're on my local VMs. Right after inserting each shard, and I will just make sure that the number of inserted records are evenly balanced. So yeah, it says 5,000 records were inserted. So now I will run the first example, which will briefly say that shard 1, which is located in node 2, says it has 2,459 records. And if we search for shard 0, it says, I will search previous one, it says it has 2,541 records. So totally 5,000. So we can notice that CUBRID shards will evenly populate both shards. So the same actually can be done with JDBC example here that I have, and I will go over the code, JDBC code. So what it briefly does, I tell that there are 2 shards, and for each shard, please let me know all the records that are available. So the first example will retrieve everything from each shard separately, and then the second example will insert 5,000 records to table post table, and it will not care, or it will not indicate where the records should go. So your application doesn't have to have that logic. So CUBRID shard is responsible for that. So once everything is important, now I can run the last empty shard example, which will briefly empty all the shards. And since it's Node.js, it can be done asynchronously in parallel. So now if we run the first example again to select everything, it will say that both of the shards are empty. So in this demo, I demonstrated how you can run certain SQL against a particular shard ID or shard database. That is, if necessary, you can, instead of indicating a particular shard, you can retrieve basically by column name and indicate that that column should be used to determine the shard ID. And CUBRID shard will get the record of it based on its sharding logic. So that's for demonstration. So you can download or fork the repository at GitHub under MIT free. And briefly to wrap up, we've created CUBRID shards with 2 main purposes, so that it's easy to use and easy to configure. And it has built-in load balancing on the API level, and it's briefly allows to avoid SPOF. You can create multiple CUBRID shard brokers on multiple machines, and each CUBRID shard can have multiple proxy processes, and each proxy process can have multiple cost processes. So that way you can load. Also, if necessary, you can CUBRID shard broker can be in 3 different modes, that is read-write and read-only or slave-only. In case of CUBRID shards, it's two modes. So if necessary, you can distribute your read loads to multiple machines this way. And it's basically heavily supported by our company MHN. And CUBRID itself is GPL'd, and CUBRID shard is GPL too. And there are still things that we have to work for CUBRID shards. There are 2 main things. One is that currently CUBRID shard does not support automatic data rebalancing. That is, if you want to add a new shard, you have to manually migrate your data from existing one. Currently, CUBRID shard does not support that. So the second issue is that we don't have graphical monitoring tool. We have a command line, but not yet graphical tool. So for those of you who have experience maybe developing monitoring tools, that may be an opportunity. So, but in the future we will work on that. So briefly, if there are services, if there are products that you run which are somewhat similar to NHNs, that is, they are stable, they are very under high loads, and you don't want to change your application, but you still want to use a sharding solution, which you can just drop between your application and your backend databases, and it's going to work. Then CUBRID Shard is quite suitable. So now I will show 2 slides about the service at NHN where we use CUBRID Shard. So NDrive is briefly our version of Dropbox or Google Drive. So it's a cloud storage system for consumers, and you can understand that every user can have lots of files uploaded to the cloud. So all the file metadata, size, name, type, location, whatever, everything is processed by CUBRID Shard. And we have 24 master shards, and they have HA, and they have the same number of slaves, 1 slave per each master. And at this moment we have 10 terabytes of data processed by CUBRID Shard. The service is quite new, and current load is that 75% around is select requests, and around 15% is the insert request. So considering these loads, we have around 3,000 QPS per shard, and this is considering only 5% CPU loads on each shard machine. So we have quite a big room for improvement if there is a high load. And in our case, we are running on a CUBRID Shard middleware, which has 4 proxies, and each proxy has around 50 CAS processes, so we have around 200 CAS processes. So CAS process is the one that actually executes the queries against shards. And in this slide, the purpose is not to show how fast CUBRID Shard actually works or performs, but actually to show that when you add CUBRID Shard, it actually does not hinder the performance of the running system. So NDrive was already running before we added CUBRID Shard. So it was running on application layer sharding, and when we added CUBRID Shard, we can notice that the performance does not decrease. It actually somewhat increases in the way that CPU load is decreased when we added CUBRID Shard middleware, and response time decreased, and number of requests per second actually increased. So this way we can guarantee that when you add CUBRID Shard between your application and end databases, it will not decrease the current performance. So right now we are thinking about auto rebalancing, haven't started yet, and the work on graphical monitoring still has already been started. So, and also we will work on some aggregation functions. Currently, you cannot perform like join operation, aggregate operations on multiple shards, and we're now working on that. So that's what I have for today. If you have questions, I'll be very glad to answer. I think I have around 5-10 minutes to answer your questions. Yes, please.
So basically you say that to convert an application to the system, I have to look every single SQL at its everywhere.
Yes, basically what we analyze on our NHN services is that even for quite complicated application, there are in average around 800 queries. So each query has to be altered to add the SQL hints. And maybe for you it can be a lot, depending on your application.
And what happens if the query comes without a hint?
So currently it will give an error so that you notice it beforehand and change it. That is, it's not gonna give an error while running. So at the beginning, when you launch, you'll get the error.
But it probably adds a lot of QA effort to make sure that every single SQL is covered.
It depends. Yeah, that's right. It depends if you have kind of control over your number of queries that you have. I think your DBA should know most SQLs. Any questions? More?
Talk a little bit about your JDBC driver.
Excuse me?
Can you talk a little bit about your JDBC driver? Is that a custom driver?
Yeah, what exactly?
So, I just saw some code that showed that.
Yes.
Is that connected to JDBC or what is that? Is it giving you special functionality for?
It's JDBC, briefly just the standard JDBC under JDBC spec 2. So it's not 3, not 4. It supports most of the functions that are necessary to running. Are actually at NHN, it's a Java world. Most of the services are running Java, so we have most of the functionality that we need in JDBC driver already available. I've seen some of the new APIs that appeared in 3 and 4. They are not supported. So it depends on your application. Any more questions? Yes, please.
So basically anything going through this is being sharded. So if you have a table that you don't actually want sharded, are you managing that differently?
Basically, CUBRID shard doesn't care about your schema. So sometimes if you want some tables not to be sharded, for some reason, I don't know, and you know exactly where it is, example, in shard 0. And in your application, you will just request to shard 0, and it will always execute the query against shard 0 and get your data from your non-sharded table and return without an error. But of course, if you try to request the same without or in a wrong shard, it will give an error, of course. But you can, if you really want to do that, non-sharded tables.
Well, it was just more around, so you're talking about storing the user's sort of like file and data, but then you got this user data somewhere.
That can be an option too. For example, if you want to generate the user ID in some separate database and keep it in one table for auto increment, for instance, in that case, you can either do that way or have that database in completely just separate instance. It depends on how you will then implement in your application. You can do that, yes.
Could the shard key be on a binary value? Like
shard key accepts kind of any value, let's say any value that JDBC driver can accept, which is string. I don't know about exactly binary, but actually it can. But in that case, you have to have your own custom library, like I told before, which will determine the shard ID based on that binary data. I haven't seen that kind of case, but if your application has that scenario, then yes. if you later, for some reason, have some idea or questions, you can email me. It's gone. I'll show you. Here. Yes. So, to my CUBRID email, or you can post your questions on our website on cubrid.org, and our developers and community members will be glad to answer.
You have other people using that already? Other companies?
CUBRID itself, CUBRID database itself, is somewhat popular in mainly our country in Korea. So, and now we've seen users using it globally in Europe as well, and we don't have like exact references in Europe or United States because we don't have a place to report that. But in Korea we have many. Yes. And our NHN kind of runs the largest farm of servers in South Korea, so lots of instances are running with NHN. And Percona team, they kind of encourage every listener of every presentation to rate the session that you're in. So please go to the same session URL, and after, I think, the end of this presentation, you will see a kind of form. I haven't seen, but you can probably see that. How much time do we have?
About 2 minutes.
Actually, just curious. So you went through some of the options you looked at, and there were some other open source ones. Is there any reason why you wouldn't necessarily spend time maintaining those versus from scratch?
Any reason for what?
For not, I suppose, why did you start from scratch instead of maybe picking one of those up?
Actually, we had some works already on CUBRID database. CUBRID database, before CUBRID SHARD, we already had HA, for instance. So it has some logic to allow us to quickly develop that. Actually, CUBRID's architecture is 3-tier, so it by default already has the middleware, which we call broker. And what we briefly did, we created a similar broker, which we call SHARD broker, which architecture is almost same as the simple broker. So there was, of course, a lot of work done, but still it was worth that. And it's quite flexible in the way that right now all that we have to do is change or add different types of classes. For instance, right now we support class for CUBRID and class for MySQL. And now we're working on class for Oracle. So basically, the architecture is identical. All you have to do is develop that CAS process only. One single process which will be responsible for connecting to the target chart. So right now we're working on Oracle. I think maybe this year we can release it.
Are there any plans, like at the moment, you have to put the hints in?
Mm-hmm. Hudson?
No, currently, you mentioned you have to put the hints in your SQL query. So you have to add various hint parameters.
I didn't hear, actually. Can you?
So as you were going through the demo, you showed us running a query, and you added a hint.
Yes.
Is there any plan to make it such that the query doesn't need a hint?
No, actually. Actually, there is a parameter which you can switch it on, and CUBRID SHARD will ignore any kind of hint. Any. Even if you insert, even if you don't insert, it will just use its own logic. But at this moment, it's not kind of available, even though it's just exist as a parameter is not enabled yet. So, but I don't see any reason to ignore that. If you ignore, it will work just like, let's say, Spark Proxy. That is, your CAS has to parse your query fully and then determine the column which probably is the shard ID. So briefly, it's a lot of work for CUBRID shard, which will definitely decrease the overall performance of your application. And that's why we have this shard ID, shard hint. It is all the CUBRID shard does is tries to find the shard hint. That's all, and based on hint, it determines the shard ID. So it reduces overall work a lot in comparison with those solutions which actually parse fully in order to determine the shard ID. Yes.
You know when aggregation is going to be implemented? Do you have a schedule for that?
It will be several step kind of incremental release. So there will be certain functions which will be implemented first. I don't have a definite list right now, and there is no exact dates for the release. We'll have a release at the end of this year too. No, not this year. We'll have beta release at the end of this year, and then the stable release beginning of the next year. So in that versions, we may have some of the aggregate functions implemented. Is there any new speaker coming?
Yes.
Yeah. Okay.